reverse Carnot cycle. Reverse Carnot cycle. Carnot cycle. So already I have told that reverse Carnot cycle. This is one of the air refrigeration cycle. Because air is used as a working substance. जैसे हम यूज कर रहे हैं क्या working situation. There are so many refrigerants are there. Carbon dioxide, sulfur dioxide, then chlorofluorocarbon, R11, R12. There are so many refrigerants are there. You can say what are refrigerants? Refrigerants are the substances which is used to extract heat from a material. So here in this case, in the reverse Carnot cycle, basically air is used as a working substances. Before we going to the reverse Carnot cycle, there are two diagrams are there. One is pressure versus volume. Pressure versus volume. Another one is temperature versus entropy diagram. Temperature versus entropy. This is a temperature versus entropy diagram. Entropy diagram. As we know that basically in a reverse Carnot cycle, so there are two isothermal process and two isentropic process are there. So in a PD diagram, so 1 to 2, there another one process, and another process. Here this is point 1 state, this is point state 2, this is state 3, and this is state 4. There are 4 states are there. In a state 1, conditions are there. P1, V1, P1 are the pressure, volume, and temperature of the air. Here in this cycle, there are 4 processes are there. Everywhere air can be circulated. 1 to 2. This is known as, who can say what is 1 to 2? 1 to 2, this is known as the isentropic compressor. Then similarly 2 to 3, this is isothermal compression. Then another one is isentropic expansion. Another one is isothermal expansion. Here, according to point state 1, the pressure, volume, temperature of P1, V1, T1. In the left, this is pressure corresponding to pressure is P1. Similarly, this point corresponding to volume is P1. This is point 2, 1 to 2 corresponding to this volume V2, and corresponding to this is pressure P2. Here at the state 3, this is P3 and this is V3. Similarly at state 4, this is P4 and volume is V4. Okay. In a reverse Carnot cycle, there are 2 isothermal processes are there and 2 isentropic processes are there. Isentropic compression 1 to 2. This is known as isentropic compression. 2 to 3 isothermal compression. Then 3 to 4 isentropic expansion. 4 to 1 isothermal expansion. This can be drawn in a temperature versus entropy diagram. In temperature versus entropy diagram. So these are the temperature versus entropy diagram. 1 to 2. That is isentropic process. 1 to 2 isentropic process. So that means entropy remains constant. That is S1 is equals to S2. 1 to 2. This is isentropic compression. Similarly 2 to 3. This is known as isothermal compression. During the isothermal process, that is temperature remains constant. That is equals to T2 is equals to T3. Then again for 3 to 4, isentropic expansion process. 3 to 4. That is S3 is equals to S4. Then last process 4 to 1, isothermal expansion process. Isothermal expansion process. That is T1 is equals to T4. Okay. So as for the reverse Carnot cycle, that is air is used as a working substance. There are 4 stages are there. Stage 1 isentropic compression process. Stage 2 that is isothermal compression process. Stage 3 isentropic expansion, and stage 4 isothermal expansion. Basically there are 2 processes are there, compression and expansion. During compression, that is compression, compress हो जाएगा तो क्या हो जाएगा, प्रेशर इंक्रीज हो जाएगा, देन वॉल्यूम एंड टेंपरेचर डिक्रीज हो जाएगा, कंप्रेस हो रहा है। सिमिलरली एक्सपांशन, ड्यूरिंग एक्सपांशन प्रोसेस द प्रेशर क्या होता है, ड्यूरिंग एक्सपांशन प्रोसेस expansion pressure decreases, volume and temperature increases here. So here 1 to 2 stage 1 the isentropic compression process, basically there are three parameters are taken: pressure, volume and temperature. During process 1 to 2 isentropic compression process, the pressure of air, here working substance is usually air. So 1 to 2 air pressure ऊपर जा रहा है, तो ग्राफ में ऊपर जा रहा है, pressure increases from T1 to T2 and your temperature also increases from T1 to T2. Both pressure and temperature increases T1 to T2, then temperature increases T1 to T2. Then volume क्या हो रहा है, volume decrease हो रहा है, the specific volume of air decreases from V1 to V2. Since it is an isentropic process क्या हो रहा है, isentropic और adiabatic process, there is no heat transfer during the process is equal to 0. So that is here is an isentropic process, there is neither transformation of heat to the system or out of the system, or during this process Q1 to 2 heat transfer during the process is equal to 0. Basically pressure increases from P1 to P2, temperature increases from P1 to P2, volume decreases from V1 to V2 and heat transfer during the process is equal to 0. After that stage 2 to 3 isothermal compression process. Now the air is again where there is a compression, that there is a device known as the compressor is there, compressor. Where there is a expansion, there is a expander, mechanical device. There are two devices used here, expander and compressor. So after 1 to 2 process, stage 1 to 2, then 2 to 3 isothermal compression. That is the air is compressed isothermally. That is temperature remains constant. Therefore here temperature remains constant. T2 is equals to T3. Temperature remains constant. So during this process 2 to 3 क्या हो रहा है? That is pressure increases from P2 to P3. ऊपर जा रहा है, increase हो रहा है. Pressure increases from P2 to P3. Then temperature क्या हो रहा है? Temperature remains constant. Temperature T2 is equals to T3. And volume क्या हो रहा है, volume डिक्रीज हो रहा है, V2 से V3 आ रहा है, volume decreases. So since it is a isothermal process, we know that heat transfer during the process, yes, there is a formula entropy के बेस करके ds is equals to dq by t. That is entropy may be defined as the ratio of heat transfer to the absolute temperature. ds is equals to dq by t. हमारा m है dq निकालना होता है, हीट ट्रांसफर निकालना है. dq is equals to आप हो जाएगा t into ds हो जाएगा. So this is a process 2 to 3 process. So we may write instead of dq, that is q2 to 3 is equals to temperature क्या होता है during the 2 to 3, T2 is equals to T3 so हम लिख सकते हैं T2 into ds change in entropy 2 से 3 आ रहा है, H2 minus H3 here, H2 is greater, H3 is smaller, so H2 minus H3, okay, H2 minus H3, or we may write down temperature constant T2 is equals to T3, और लिख सकते हैं T3 into H2 minus H3 समझ में आ रहा है. और H2 is equals to S1, हम लिख सकते हैं S1 minus S1, और लिख सकते हैं T2 into S1 minus S4, और भी हम लिख सकते हैं T2 into S1, T3 into T2 equals T3 into S1 minus S4. समझ में आ रहा है. During this process 2 to 3 process, the heat absorbed during the process is equals to, that is the air can heat absorb T3 into H2 minus S3 or this one. Then another process is 3 to 4. After that the air is again passed to the isentropic. There is an expander is there. Expansion takes place. During the expansion, that is pressure decreases from T3 to T4. Temperature is also decreases. During this process, temperature also decreases from T3 to T4. Since it is a isentropic process, isentropic or adiabatic process, neither transformation of heat transfer during the process is equals to 0. Heat transfer. So we may write down during the process 3 to 4 pressure decreases from P3 to P4, temperature decreases from P3 to T4. Expansion process, volume क्या होता है, the specific volume of air increases from V3 to V4. Specific volume of air increases from V3 to V4. समझ में आ रहा है? Okay. So since it is an isentropic process, that is heat transfer during the process Q T24 is equals to 0. Isentropic process, neither transformation of heat energy to the system or out of the system. Next process, after that the air passed to the isothermal expansion process. Expander is there, then isothermal process. Now the air passed from the 4 to 1 process, expansion takes place. During the process the pressure falls from P4 to pressure आ रहा है P4 से P1, pressure falls from P4 to P1 and temperature during the process, temperature remains constant, T1 is equals to T4 and another one क्या हो रहा है, volume increase हो रहा है, volume increases from P4 to P1. Since it is a isothermal expansion process, we know that same procedure ds equals to dq by t हम लिख सकते हैं, ds is equals to dq by t. Since it is a isothermal process, our aim is to find out the amount of heat transfer. dq is equals to t into ds, dq. Here we can consider 4 to 1 process. 4 to 1 ले रहे हैं ना? That is q4 to 1 into t के बदले लिख सकते हैं t1 और t4. t1 into ds. Change in entropy. S2 minus S4. S2 minus S4 और हम लिख सकते हैं T1 के बदल और क्या हो जाएगा T4 into S2 minus S4 और S2 के बदल लिख सकते हैं S1 और S3 के बदल में S4 लिख सकते हैं. These are during the heat transfer. ना समझ में नहीं आ रहा है. So now we have to find out the COP of the refrigerator. Okay. Now we have to find out COP of a reverse Carnot cycle. COP of a reverse Carnot cycle. Already I have told that in a reverse Carnot cycle, how much? In a COP of a refrigerator के लिए COP का क्या फॉर्मूला था? COP it is the amount of heat extracted from that body to the work done, amount of heat extracted. So COP of a reverse Carnot cycle is equals to Q4 to 1 divided by Q2 to 3 minus amount of heat supplied and amount of work done. Okay, Q4 to 1 divided by Q2 to 3 minus Q4 to 1. Okay, this is known as the reverse Carnot cycle का ये होता है COP. COP of the reverse Carnot cycle is equals to COP के बारे में Q4 to 1 minus Q2 to 3 minus Q4 to 1. Or we may write down Q4 to 1. Here already I have write down Q4 to 1 is equals to T1 into this much. और हम लिख सकते हैं और equals to Q4 to 1 is equals to T1 into ये लिख सकते हैं हमारा S2 minus S4 और S2 minus S3 एक टर्म में ले जाएंगे S2 minus S3 S2 minus S3 एक ही टर्म में लेंगे तो कैंसिल करने के लिए इजी होगा. So T1 into S2 minus S3 divided by work done is equals to Q2 to 3. Here that is Q2 to 3 ये निकल जाएगा ये वाला और equals to T2 into एक ही टर्म रखेंगे S2 minus S3 minus of Q4 to 1 T1 into S2 minus S3 और equals to here taking common ये चले COP T1 into S2 minus S3 divided by T2 minus T1 हो जाएगा कॉमन ले जाएंगे T2 minus T1 इक्वल है S2 minus S3 S2 minus S3 so into S2 minus S3 तो here कैंसिल हो जाएगा S2 minus S3 कैंसिल हो जाएगा तो फाइनली the COP of a reverse Carnot cycle is equals to T1 by T2 minus T1. This is the final relation. Our main aim is to find out the COP of a cycle. ये रेफ्रिजरेशन चैप्टर में जितना पढ़ेंगे और मेन एम है हर कोई साइकिल को हमको COP निकालना है. COP is equals to T1 minus T1 divided by T2 minus T1. Okay. तो लास्ट क्लास में ऑलरेडी हम फिगर कर चुके थे याद है तो एक रेफ्रिजरेटर का फिगर हुआ था रेफ्रिजरेटर दिस इज इक्वल्स टू थर्मल रिजर्वायर दिस इज व्हाट है नोन एज सोर्स पार्ट दिस इज Q2 अमाउंट ऑफ हीट दिस इज ऊपर जाएगा Q2 दिस इज Q1 दिस इज सिंक T1 ओके समझ में आ रहा है एक फिगर किए थे ना एंड दिस इज वर्क डाउन ऑन द सिस्टम work down. So T1 T2 ये lower body temperature T1 this is higher body temperature T2 okay समझ में आ रहा है this is finally COP equals to T1 by T2 minus T1 okay? तो COP में भी इंक्रीज, COP कैसे इंक्रीज हो जाएगा, जब हम T1 इंक्रीज होगा तो COP इंक्रीज हो सकता है, और डिक्रीजिंग तो हायर बॉडी टेम्परेचर जब T2 डिक्रीज होगा तो इंक्रीज हो सकता है COP, और जब हमारा T1 इंक्रीज होगा तो COP इंक्रीज हो सकता है। समझ में आ रहा है? ठीक है, क्लोज कर दो। मैं